Okay, so in this second part of the lab, we're gonna start dealing with the normal distribution in R, right? And so, normal distribution in R. So for the normal distribution, there are three major commands. The norm, which gives you the value of the PDF or probability density function, right? Which is the value on the curve corresponding to a certain x, right? And if you guys need to know or remember, just go on the lecture slide and check what we mean with PDF, right, or probability density function. And with second command pnorm, it instead gives you the actual probability, right, or the area under the curve. Okay, pnorm gives you the area from minus infinity to x. That's why it's very important to visualize things when you do the calculation in terms of areas and graphically. And then there's qnorm, right, which gives you the returns the value corresponding to a certain probability, or to a certain area under the normal curve. So let's assume we're looking at the population of 4 to 6 year old Italian kids, right? Or let's assume that Italian kids are normally distributed. Italian 6 years old kids, height is a random variable which is normally distributed with mean 131 centimeters and standard deviation of 10. So what value of the PDF or of the curve correspond to a height of let's say 138. So again, I'm looking for the value on the curve, right? The value, not the area. So I'm using the norm. The norm 138, comma, mean equal 131, comma, SD equal to 10. And tells me that the value on the curve is 0.03. Why do I care about that? Because I can do something like I can wrap this into an array and, for example, say my normal array is equal the norm, I don't know, just like minus, no, let's say 100 to 180, mean equal 131, SD equal to 10. sorry, I have to do this, right? I can say plot this versus my normal array, and I get some sort of normal distribution. Very simple and brute way to actually do a normal distribution plot, right? You can also do it in a more if you want to do this in ggplot, for example, you can actually say, okay, let's call df as dfx, let's say, goes from minus 180 seek, say minus 1 I don't know, 50 to 180, okay? Fifty to 180. Doesn't like it. Okay, say df x 60 50 to 183, y is equal to the norm. I'm gonna substitute x now. I can call df data frame x comma y. Let's look at df. Here it is. Now I can use ggplot. Say ggplot df comma as x comma y plus geomline, for example. And we get something like this, right? You can make it plus team bw plus, you can say xlab height. You can say ylab is a pdf team bw. Okay, great. Now let me add here for your reference that this is using ggplot. Now, what fraction of kids is shorter than 160 centimeters? As I said, I'm going to use p norm. So I say p norm, right? 160 comma mean equal to 131, SD equal to 10, and basically 99%, right? Around here, 99% is going to be less than 160. Okay. Other question is, what fraction of kids is between 135 and 145? Centimeters. How do you do? Right, remember, p norm goes from minus infinity to your value, right? This means to do what? P norm 145 comma mean equal 131 comma SD equal to 10 minus p norm 135 mean equal 131 SD equal to 10 again, and 26% are included between a height of 145 and a height of 135. Okay. Finally, what fraction is larger than 150 So remember, p-norm gives you from minus infinity to the value. We want the complement, right? So we use 1 minus p-norm. Use 1 minus p-norm. And so we do this. 1 minus p-norm 150, comma, mean equal to 131, SD equal to 10, and basically almost only 3% is gonna be higher than 160.